Hello, and welcome to today's lesson on activation energy and collision theory. In this lesson, we will start off by grasping the concept of activation energy. We will then go on to understand how collision theory explains the role of activation energy in determining reaction rates. So far, you've become familiar with reaction energy profiles. These profiles depict the energy changes that occur during a chemical reaction, illustrating the difference between the energy of the reactants and the energy of the products. Building on this foundation, today's lesson will elaborate on the concept of activation energy, advancing our chemical understanding by explaining why not all collisions between reactant particles result in a chemical reaction. By understanding the importance of proper collision orientation and sufficient energy, we will deepen our insight into the factors that influence reaction rates, opening up new avenues for controlling and optimizing chemical processes. So, without further ado, let's get into it. As mentioned in the previous lesson, activation energy is the minimum amount of energy that reactant particles must have for a chemical reaction to occur. You can think of it as the energy barrier that needs to be overcome for the reactants to be transformed into products. Imagine trying to push a heavy boulder up a hill. You need to put in a lot of effort to get it moving. Once it starts rolling down the other side, it goes easily. Similarly, in a chemical reaction, activation energy is the minimum amount of energy needed to get the reactants to start reacting and form the products. It's the push that gets the reaction going. Different reactions have different activation energies depending on the reactants involved and the reaction pathway. Collision theory provides a framework to understand how chemical reactions occur and why different reactions happen at different rates. According to collision theory, for a reaction to occur, the reactant particles must collide with sufficient energy. The particles must collide with energy equal to or greater than the activation energy. If the energy is too low, the particles will simply bounce off each other without reacting. Imagine playing a game of pool. If you hit a ball gently, it might touch another ball but not move it much. Similarly, molecules need enough energy when they collide to break old bonds and form new ones. Reactant particles also must collide with proper orientation. The particles must collide in a specific way that allows the bonds to break and new bonds to form. Even if the particles have enough energy, an incorrect orientation during the collision will not lead to a reaction. For example, think of two puzzle pieces. They need to fit together in the correct alignment, the proper orientation, to form the bigger picture, the product. During a collision, if reactant particles possess energy greater than or equal to the activation energy, they can overcome the energy barrier, resulting in a successful reaction. This is often represented in reaction profiles, where the energy of the reactants rises to a peak, the activation energy, before falling down to the level of the products. The activation energy plays a crucial role in determining the rate of a reaction. If the activation energy is very high, only a few molecules will have enough energy to overcome it. This means that the reaction will occur slowly because fewer collisions have the necessary energy to result in a successful reaction. Conversely, if the activation energy is low, more molecules will have enough energy to overcome it. This leads to a faster reaction because a greater number of collisions can overcome the activation energy barrier, resulting in more successful reactions. Let's return to our boulder and hill analogy. If the hill you were trying to push the heavy boulder up was very small, you'd be more likely to get to the top faster. However, if the hill was very large, you'd be less likely to reach the top. And even if you did, you would be much slower. This is very closely analogous to activation energies. In today's lesson, we delved into the concept of activation energy and how it acts as the energy barrier that must be overcome for a chemical reaction to occur. We learned that activation energy is the minimum energy required to transform reactants into products, akin to pushing a ball over a hill. We then explored collision theory, which explains that for a reaction to occur, reactant particles must collide with both sufficient energy and proper orientation. These criteria ensure that bonds in the reactants can break and new bonds can form, leading to a successful reaction. This knowledge provides valuable insights into optimizing chemical processes.